All right, welcome finally to step 6, the last of our steps. Um, to recap, step 1, draw the free body diagram for our car being towed. Step 2, choose a positive direction. Step 3, create the force chart. Step 4, add the columns. Step 5, set it equal to m times a. Each component equals to m times a. One or both member of the components of the acceleration will be 0. And finally, step 6 is to solve. What do you end up with? You end up with, if I get my magic pen here, um, you end up with two equations, one here and one here. For each mass, you're going to end up with two equations. Okay, here's the free body diagram. Here's my choice of positive direction. Remember, the signs here in your chart are going to be determined, or going to be positive or negative, depending on your choice of positive direction when you choose the components. Okay. Um, Now, I haven't given you any numbers, which is probably driving you all crazy, but notice what I have done here, okay? Um, that's why it's in bold and it's red. Um, all I did was to draw this picture, okay? And we decided, or I decided, I guess, I decided the problem was about the car being towed, okay? Just based on that, I didn't have, you guys knew what forces are acting. You may have messed up the direction of the tension, perhaps. You might have said it was to the right, or some of you might have said it was just up. But, as you, in that case, you were half right. It's up and to the right. Um, so you know what forces are acting. Um, you just follow the procedures. A lot of the steps are, I don't want to say mindless, but there's not a lot of thought there. Remember, the first place you actually have to think really is, what do you put in for the accelerations, right? Since it's moving horizontally, the vertical component would be 0, and the horizontal component would take the full value of the acceleration, right? You end up with two equations, one here and one here. The fact that one of them is equal to 0 just makes that problem easier to solve. I mentioned before, by the way, that the normal force was determined through the process. This is what's going to give you the normal force, right? Typically we would find the normal force from the y component. And remember, I said that the friction was related to the normal force. You would find that normal force and stick it in to the expression for the frictional force, right? Um, but you end up with generally two equations, so you end up with simultaneous equations to solve. That's for a problem where you have one mass. If you have two masses or three masses or four masses, I mean, the intro video that I had a mass on an inclined plane, another mass hanging off by a pulley or a string attached to a pulley. You would do this free body diagram for the mass that's hanging. You do this free body. You do the 6 steps for the hanging mass. You do the 6 steps for the mass on the inclined plane. Once you've done that, you have 4 simultaneous equations through these any problem that I can possibly ask. I didn't ask a problem here. I didn't ask any question. I simply drew a picture, right? No matter what question I could possibly come up with, the answer is someplace on this page. Okay. Typically, what's going to happen is you're going to be asked to find the acceleration, or you're going to be asked to find what the tension was, or you're going to be asked to find the frictional force, or what have you. Okay. But no matter what the problem is that I would ask, and I might ask more than one, the answer to any question I could possibly ask is going to be someplace on this page.